Welcome to the Dynamic Learning Hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So
Very good afternoon to one and all present today. I would request the faculties to inform your fellow mates to quickly join in so that we would be starting the session in the next 5 minutes. Shushmita, I hope all the guests have joined in.
Yeah, yes, ma'am. They all on.
This will be a last call for the faculties to inform the other faculties to join in quickly as we would be starting the session in another minute. A warm welcome to all the dignitaries who have joined in for today's afternoon faculty development program on quantum computing. So let me introduce you to Mr. Amit Saha, Associate Director of XLR, who will be taking over for now. Over to you, Amit.
Yeah, thank you so much, Nitya. I hope I'm audible. Let me
Yes,
share my
Amit, you are
screen.
audible.
Yeah, if I just once confirm quickly whether my screen is visible.
Yes, Amit.
Fantastic. So, hello and welcome to all the eminent academicians who has joined in from all across the country and maybe some beyond the boundaries of our country as well for continuously making this particular program of faculty development, which falls under the prestigious everyday learning program of XLR, uh, for making your time and joining in, and as always, constantly supporting this initiative. Before I delve into the details of the program and rather, about quick bits about XLR and the journey of XLR. First of all, uh, we are taking probably a little bit of a shift from the conventional programs that we have been doing all these days over the last 36 months, and moving into a space which are more into the emerging tech and niche areas. And I'm really glad to be hosting this program today, which is on quantum computing. I mean, this is basically the beginning of this 5 days journey into this quantum computing, where all of you would be exploring how quantum computing processes information using the laws of quantum physics and enabling quantum computers to solve certain complex problems much faster than the conventional or regular computers. It's really so exciting from a layman's perspective to even imagine about the applications of quantum computing in all walks of life, and in the industrial domains as well. For example, talking about medicine and drug discovery, we can probably imagine testing millions of molecular combination in hours instead of years, speeding up the cures for diseases. Or in banking and finance, spotting the fraudulence factors much more faster and making smarter investments predictions at a much more shorter timelines and by crunching massive data sets. Similarly, as we know, we probably our export on today for quantum computing would be definitely highlighting on the multiple other areas of application, in whether it is in logistics and supply chain or in cybersecurity, or making the possibility of training smarter AI models, making it faster and thereby processing the complex data patterns. So this is another jump or another kind of a new initiative for us, that although we have been conducting these programs on the emerging tech, now probably within the emerging tech also we are gradually moving into a space of much more niche areas. Today it is about quantum computing. Sometime down the line we would be definitely again delving into blockchain or AR, VR, augmented reality or virtual reality and so on. And we would be very to also get the feedbacks from all of you, that whether these initiatives would be exciting for you all, and would look forward for such things to come in near future as well. So moving into the space of everyday learning for students, faculty, and colleges, which the platform which is well known for all the participants and for the guests. Please don't be worried as you see the numbers of participation in this particular Zoom link, because probably for only for this today's curtain raiser program, we have kept it limited only for the invited guests, and there is a huge lot of learners from the faculty and academia and the students who have joined in our YouTube live, which counts on today's current timeline. It is almost crossed more than 1,000 and continuously increasing. So yes, today we are talking about quantum computing, and just to move before we move on to the core, training area, just a quick glimpse about the journey of XLR as we started, as you all know, that around 11, 12 years back, way back around end of 2013, in Bangalore and in Hyderabad simultaneously. And then from 2016-17, we launched the data science and artificial intelligence programs, and there has been no looking back from there on. As time progressed, we started off our ventures and offices in Mumbai, and then in Pune, and then in Mumbai, and then gradually we are moving into the space of exploring possibilities of opening up in Delhi and Chennai as well in the coming days. Subsequently, in 2018 and around 2022, two times we have been awarded amongst the Deloitte's fastest 50 growing tech companies. We also had a strong collaboration with Steinle's University, Germany. And from probably three courses, we today have moved on to more than 70 plus courses being live from paltry, single-digit employee strength to today almost, reaching a figure of close to around 500, and also strengthening our partnership with NASSCOM Future Skills Prime and MeitY, Ministry of Electronics and Information Technology, and having our physical offices, branches, and training centers across 7 locations. We also have, significant improvement in our academic collaborations in form of, having formal collaborations with IIT Madras, IIT Jammu, SWAYAM Plus, apart from NASSCOM, which I have already mentioned. So this has all had been possible because of the visionary leader of XLR, under whose guidance we have been taking the whole initiative forward. That is Mr. Ram Tava, who happens to be the MD and CEO of XLR, who being an alumnus of IIM Calcutta, spent close to around 3 decades in different capacities and leadership roles across the different IT companies, both MNCs and domestic. And of course, the primary, the factor that his passion towards training probably made the sense of launching XLR to see that dream happening in reality. Ably supported by Mr. Srinivas Reddy, director, who is also an alumnus of ISB Hyderabad, an engineer by his academics, and spent close to around 17 years in the corporate world, majorly focusing on areas of statistics, machine learning, and deep learning, and worked as data scientist in multiple leading organizations like Cyient, Infosys, Accenture, and his last association being with Mercedes-Benz R&D, research and development, as a senior data scientist. Srini's passion also had been as a data science trainer and evangelist. So he has worked in applications of data science in the area of aviation, telecom, banking, and automotive domains, and trained more than 3,500 faculty and more than 10K students across the globe, and has many publications of research articles to his career. In our course of this, delivery, we have also had multiple collaborations. When we look at the different skilling bodies, nationally, we are formal associates of I have Divya Sampark, which is a joint initiative of IIT Roorkee and DST, Department of Science and Technology, Government of India. In the state of AP, we are having formal collaborations with AP State Skill Development Corporation and AP State Council for Higher Education. In Telangana, we are formal partners of Telangana Academy for Skill and Knowledge, and similarly in other states like in Karnataka and Tamil Nadu and so on. We also are formally associated with some of the major academic entities who are of course considered as the temple of learning, not only in India but worldwide, like having formal collaboration with IIT Madras, IIT Roorkee, and IIT Bombay, along with BITS Pilani. And we are ably supported by the, through the strength of our association with NASSCOM Future Skills Prime and MeitY, which I've already mentioned. And recently we have collaborated with SWAYAM Plus for the NSQF and NCRF approved programs, which we have launched recently. For details, of course, our team will get in touch with you, or you can, connect with us to showcase that for further more details on the same. In this course, we have also been awarded and recognized for our efforts by Deloitte, Silicon India, Analytics India, and so on. Now, just to show you a certain, output of whatever the effort that we have done, what kind of reach that we have been able to, procure on today's date. So, through our everyday learning program, especially the faculty development program, which you are part of today, we have currently close to around 75,000 plus faculty members coming in from STEM and non-STEM domain who are constantly utilizing our platform for their continuous upgradation and upskilling endeavors. And similarly, more than 8 lakh students are part of this particular platform for participating in the student development programs. This has all been possible primarily because of the formal memorandum of understanding that we have been able to do with more than 2,000 plus HEIs, higher education institutions. And we are also doing continuous the support to them for conducting webinars and seminars on specific domain for career orientation of the students to take a well-informed decision regarding their careers. Uh, the faculty development program and student development program under the EDL platform are exclusively by XLR and as per the calendar and the requirements published by XLR. The overall breakup that you might see about the participation, of course, it is heavily loaded towards engineering, but when we look in from the non-STEM background also, there has been a substantial participation for the SDP student development programs and as well as the faculty development programs. And that that kind of an activity continues program after program. If you look at the specific program of quantum computing that you are all attending today, so you see the exact head count as per today's morning, the number of participations that we have received. Even you can see the state-wise participation. Of course, there are peaks coming in from Maharashtra, Andhra Pradesh, Telangana, Karnataka. But you can even see that when we see our footprints are gradually increasing when we look at the northern part also, Uttar Pradesh, Gujarat, and so on. Of course, the topic being quantum computing, that I definitely, we can realize that the reason for more engineering faculty members participating for this specific program. But overall, there has been, equal level of participation coming in from faculty coming in from the non-STEM domain as well. As on current date, we have conducted more than 45 plus faculty development programs, and our total repository is close to around 450 plus hours of learning content that we have created through these faculty development programs. And all the faculty members who joins in at any given point of time gets the access of that particular library. And these are all on best of the emerging technologies like agentic AI or Gen AI, deep learning, and different AI concepts, the data analytics tools using Power BI and Tableau. In fact, that we have just concluded last week on data analytics and Power BI. So similarly, this has been the more popular programs where we see more participation from the faculty members. So on that note, I welcome everyone for this curtain raiser program of the faculty development FDP faculty development program on quantum computing. And I'm really elated and privileged to have with us some of the distinguished guests for today from the academia, many of them who are also having a rich balance between academia and as well as industry exposure. And without wasting any time, I would like to invite the first guest from the academia who has also left a lot of stamp in his rich experience in the industry as well, and a good friend of mine, Dr. Suman Bhattacharya, who happens to be the director of Career School, KIT University, Bhubaneswar. Uh, of course, he is having more than 2.5 decades of experience in IT services, product development, and academia, which includes, as I already mentioned, 13 plus years at TCS and AI-powered digital innovation. He is currently a professor and PhD guide in computer science, and based on his expertise in AI, machine learning, software engineering, and so on, and has, to his credit, more than 47 research papers, nationally and internationally published. And he's also not only reserving his whole knowledge and initiatives within the campus of KIT. He is also very open to reach out to any who would like to approach him for the developments that they would like to require. And that's where he is member of governing bodies at IGNOU, UPS, and 6 other universities, and drives even academic reforms and research initiatives out there. So on that note, I would invite Dr. Bhattacharya to please share his thoughts on this particular program, the topic, the exciting topic that we have brought in today, and overall the reforms that he has been initiating and his thoughts regarding the current academic or the bridge of the academia and the industry on today's date. From We look forward for his views. Over to you, Dr. Bhattacharya.
Hi, good afternoon. Hope I'm audible to all of you, right, Amit?
Absolutely, clear and
Yeah,
clear.
yeah. Great. So, good afternoon, all the faculty members and the esteemed guests from different universities and industry, and also the esteemed member from XLR. So, today's topic, of course, very exciting. Looking into today's business scenario is concerned. Uh, though quantum computing is still not seen the entire industry look because of various reasons, I can say. But the quantum computers that which we are talking about here today, maybe it has got immense applications, and the great advantage is that solving the complex problems. So, why today world is looking after NVIDIA systems and all, because uh, the chips are solving the complex problems. But the entire crux is that when you talk about the chip solving AI problems, is getting heated up, and a lot of power is getting dissipated, and you need a lot of such complex algorithm to run, and you need the processor speed, you need GPUs and all. So when quantum computing comes, automatically those things will definitely fade away, and we'll see a better way of solving the problem than what today's AI and machine learning is doing, right? So that is the biggest advantage of quantum computing, I can say, is to solve a very complex problem and exponentially faster than the classical computers today. So what speed we talk about today is definitely quantum computers will give 10, 20, whatever times you can say, they're going to give the faster. With applications, the biggest, cryptography or cryptocurrency, you talk about the finance sector, there is another, you need very secured way of computation needed is cryptography. So that is what the quantum computers can do much better than the conventional computer. Then you talk about optimization, you talk about the problems on, simulations. And when you talk about simulation means I need to visualize AR, VR sort of thing to simulate the things before I actually get into the real time applications or real-time manufacturing, right? So looking into all these aspect of quantum computers, I also today morning requested Amit to why don't in the session itself, because the concept itself is just shift, and shift from a conventional computing to quantum computing, and how if I talk about the complex problem solving, then how actually the problems will be solved from different verticals of industry today. Mainly, if I talk about how the shift can happen from AI and machine learning on a more complex framework to more quantum computing based solutions. Then another very big examples I can give from a cybersecurity area, where every now and then there is a data breach threat and all this thing, how we can actually secure our entire data, because today whole world has moved into cloud, and the algorithm which runs on this on top of it are working on that line. So if I am not secured enough, so definitely from when I talk about military or financial sector, anything you talk about, I need to secure all those data points. So cybersecurity is another area in which quantum computers can really make wonders. Then next is because it is originate from the physics, as Amit told. So material science and engineering is a huge, application to simulate material behavior or optimize the battery performance. We see today EV segment. We don't know how to optimize this battery performance. So quantum computers can actually help in optimizing the battery performance and discover new materials with the desired properties, which can be used for replacing such kind of combinations. Then, as I told, financial modeling and calculations in the industry of BFSI. So quantum computers can improve the financial modeling, then portfolio optimizations. Like today, if you ask me, I have got say 20 companies have invested money, but I just go and check which one behaving properly or not. Then I do buy and sell and all this thing. But if my algorithm can actually tell me, looking in the past data of the similar kind of investor who has done it, so that a lot of processing is needed. So quantum computers can do a lot of good work in both portfolio optimizations or a risk management on investing on some new fund or something like that, right? So it can also enable faster and more accurate predictions, basically how the market will behave. So that these are the financial modeling application of quantum computers, we can say. Then today is logistic and optimization is another area in which supply chain, this there also the complex problem is, every world has moved into e-commerce to quick commerce, right? So now looking into the inventory to the products to the delivery to how it is being delivered, then suppose something is not right, product is not right, how to take the product back. So it's a very, very complex supply chain, logistic and optimization. So there conventional computers also fail or maybe takes time to compute. So quantum computers can really eradicate. So then drug discovery, already Amit has told. Then environmental modeling and smart energy is another area in which actually we can really work on this, optimize the energy system or predict the climate pattern, how to model complex environmental system, etc. So this is very, very, very. So weather forecasting also another area. Automotive industry also, because it's gone into hybrid mode. So you need a lot of data driven or automation is happening in the automotive industry. So these are the few examples I wanted to cite, because see, we do not want to see quantum computing as a more theoretical concept rather than how engineering applications are being built around it and how the whole world can actually get a different shape altogether. That is what my expectation from the faculty. If you can highlight some of these, industrial applications, some of the algorithm, we can bring it out and discuss with our faculty member in the FDP program throughout the week, whatever we have planned. So definitely add a lot of value and more interest to participate in this program. So thank you, Amit, for this wonderful opportunity to me, and all the best to everyone in this forum. Thank you.
Absolutely. Thank you so much. And it's really great that the kind of spread that we have also been able to reach out to the students of KIT University and as well as to the faculty. I'm sure that they will also be equally excited to participate in this particular program and as in our future programs as well. Thank you so much, Doc, for your well thought out discussion that you have put through from
Yeah.
your end.
Yeah. Thank you.
So
Thank you
moving
very
over,
much.
thank you so much. Thank you so much. Moving over to again one of my very very close friends from the academia and always a great supporter in the initiatives of XLR for with whatever the activities that we have been doing. I would like to invite the next guest from the academia, Professor Dr. Amar Singh Vidate. So he is the professor and head of the Department of Computer Engineering, as well as the chairman of Training and Placement Office in RAIT, the School of Engineering in Dr. D.Y. Patil University, Mumbai. Holds a PhD in computer engineering and with a specialization in wireless networks. And I also feel that he is also, ably, the right kind of brain to probably relate to the topic that we have chosen today. So he brings with him almost close to around 3 decades of academic and industry experience in programming, public speaking, and leadership. He actually looks forward for shaping the new generation for getting into their first career, for first career entry, and and also oversees that they can shape up their future career in the right way. He is a recipient of multiple awards for research in wireless networks and mobility management and drives student-centric innovation and successful industry collaborations for enhanced placements. So, over to you, Vidate sir, to share your thoughts on this particular topic. The all the strong and long collaboration that we had already had with your esteemed institution over these years, and of course, the based on your interest and focus also, as you mentioned, that there are certain great initiatives which is happening at the university as well on quantum computing. I would probably request you to take over the stage and share your thoughts on the same.
Yeah.
Over to you, Dr. Vidate.
Yeah. Thank you. Thank you. Thank you, Amit sir. Hope I'm audible.
Absolutely, sir.
Great. Thank you so much. Great energy, I would say. A great topic. It's so emerging, but still So before I actually start, so good afternoon to everyone, to all the distinguished guests, organizers, speakers, faculty members, and of course, if there are some students, welcome to students also. So it is my great honor to welcome you, for this FDP program, which is curated on something very special, very, very emerging, that is quantum computing. And above that, one more layer I would like to add, which is organized by XLR, under their everyday learning platform umbrella, which is something, very different. And I know their programs, which happens under everyday learning for faculty development. And so many programs, looking at the registration count of 8,000 plus and all, like, XLR is doing a fabulous job, I would say, because helping the faculty, which we firmly believe, uh, train the trainer, which would be really, really, uh, I would say, a service to the uh, nation, service to the students community. So Amit Shah sir, is like, always so interested, and the way you people take the buzzwords, right? This is really amazing, right? You're doing as a associate director, you are doing a fabulous job, I would say. XLR and the entire, entire your team, you people are doing wonderful job. Now, if I remember, for decades, where classical computers relying on bits like zero and ones have been powered our progress. And then from we have done, like, moon landing, and then to the artificial intelligence, right? But as a challenge grows, as far as cryptography is concerned, climate modeling is concerned, optimization is concerned, AI is there, and then drug discovery, right? Dr. Suman has just mentioned about it. The limits of classic computing is very clear now, right? We have recently heard about, a few years before HPC and all, but still, that limitation is quite clear. Quantum computing is not just a faster computing, it's a paradigm shift. Okay. It uses qubits capable of superposition, holding both zeros and ones at the same time, and entanglement, enabling coordination in ways classical logic simply cannot match. You know, uh, why I would like to put a few points why such FDPs are important, right? Because this type of FDP, which is on so much a recent topic, right? It's not just a training program, it's a preparation ground for the quantum future, right? I would say it's a quantum future. And over the coming days, uh, you people, I was just going through the contents where you'll be focusing on mathematical foundations, right? Then quantum gates and circuits, core algorithms, which are so famous. Siemens is there, Clovers is there, Shor's algorithm is there, quantum hardware entanglement in practice, and then emerging research areas like quantum image cryptography, biosystems, and hybrid computers, classical AI, so on and so forth, right? So I, I was going through Dr. Amit Raj, who is one of the, speaker for next so many days, bringing deep interdisciplinary expertise that bridges physics, material science, and of course AI. So as far as my institute is concerned, Ramrao Institute of Technology, which is under DY Patil, deemed to be university. We are already ventured into quantum, and this type of program which will really help my faculties. It will give the research directions, right? So on and so forth. Some of the capabilities, I would say, like, quantum key distribution test bed. I'm talking about the laboratories which are typically the facilities which are available here, right? So quantum key distribution test bed, then access to Pennylen, Qiskit, and Crick, for the quantum algorithm simulation and execution. And then research, already the research has been initiated into quantum cryptography, error mitigation, network system, and quantum machine learning. I would say this would be a great hybridization when we talk about quantum and machine learning. So, and thanks to the XLR for bringing all these pointers to the faculty fraternity. Okay, and definitely, such programs which will add. I remember one of the say, like, Richard Freeman once said, "What I cannot create, I do not understand." Right. So I'm very sure by end of such FDP or this particular FDP, like you'll not only understand you'll not only understand the quantum computing, but you will also begin to create to it through algorithms, simulations, and bold new research ideas. So, on behalf of especially my institute, RAIT, I once again thank you, XLR, and the umbrella of everyday learning for making this program possible. I welcome all the participants once again, and I'm sure it will be inspiring, challenging, and transformative learning experience. Thank you. Thank you, Amit sir. Thank you, entire XLR team for having me. Thank you so much.
Thank you so much, Vidati sir. As always, you have been keeping such sweet words for XLR and team, and such support actually gives us the continuous oxygen for creating new initiatives, bringing in new topics, and exploring possibilities of keep on bringing the freshness in the platform that we have already created over the last 3 years. But absolutely rightly said, our target has never been to replicate typical, again, once more, a theoretical classroom in these sessions. That is the reason why we discuss very deep with the subject matter experts or the industry experts who are primarily the resource person, and try to discuss about that how it can be made more engaging. And I can assure everybody that of course, I will be introducing the person very soon in the next 4 or 5 minutes. But we have already discussed, and will ensure that it becomes more engaging, more hands-on, more application oriented, rather than just a theoretical transfer of the knowledge. So, and that has been the primary strength and focus of XLR to bring in these everyday learning sessions, irrespective of whether it is targeted towards a faculty or a student. So, once more, thanks a lot for Professor Amar Singh Vidate for ensuring that his institute becomes a collaborative partner for this particular program, and as well as spending your time on this particular platform to encourage all participants. And moving on to the third collaborating institution, a very famous institution from the state of Karnataka, and especially in Bangalore, coming from the New Horizon group of institutions. I have Dr. V. Asha, Professor and Head of the Department of MCA, New Horizon College of Engineering. Dr. V. Asha, PhD in Computer Science, is a Professor and Head of MCA at New Horizon College of Engineering, with almost more than 3 decades of academic excellence. Her expertise being in digital image processing and pattern recognition, and more than 100 plus paper publications, and filed 40 patents and guided funded projects. She has also, explored and experienced in the areas of being a research guide under the Visheshwaraya Technical University recognition, and an active mentor and industry academia, person for collaboration and trying to foster innovation in education. Thank you, ma'am, for ensuring that your esteemed institution join hands with XLR as a part of our formal MOU, and also making yourself available for the launch of this fantastic FDP program on quantum computing. So now I would request you to please share your thoughts regarding this particular program, and as well as your suggestions for the participants as well. Over to you, Asha ma'am.
Thank you, Amit sir. And good afternoon, everyone.
Very good afternoon, ma'am.
It's a pleasure to welcome you all to this 5-day faculty development program on quantum computing, jointly organized by various academic institutions in collaboration with XLR. I would wish to talk about our college, New Horizon College of Engineering. It's an autonomous institution affiliated to VTU, approved by ACTE and UGC, accredited by NAC with an A grade and NBA. It's located in the heart of Bengaluru's IT corridor. We are surrounded by global tech leaders like Intel, Wipro, JP Morgan, and Cisco. We are proud to inform that we, the Department of MCA of New Horizon College of Engineering, has signed an MOU with XLR aimed at strengthening industry academia collaboration in emerging technologies like AI and data science, Gen AI and prompt engineering, quantum computing, NLP and ChatGPT, business intelligence through these faculty development programs and certification. Coming to today's topic, quantum computing, it uses the unique powers of quantum mechanics to tackle problems that traditional computers cannot handle. It has great potential to transform areas like cryptography and drug discovery, driving the future of technology and innovation. We are grateful to our expert speakers from academia, industry, and industry for being part of this FDP. Special thanks to XLR for their valuable partnership and to the Department of MCA for organizing, for having this collaboration with XLR. It's also nice to note that we have participants from various states, and again, it's in a very big number. So to all the participants, make the most of this opportunity and let this FDP spark new insights and inspiration. Wishing the program the great success. Thank you.
Thank you so much, Dr. Asha ma'am. Yes, definitely. We have recently collaborated with your institution and definitely looking forward to walk miles together on this endeavor to continuously provide an environment for learning for students and as well as the faculty members. And looking forward for strengthening the same and engaging in more collaborative initiatives. So on that note, I'm really excited once more for introducing to you the person whom everybody, all of you, had been waiting for, and of course, he will be the person with whom you would be spending for the next spending time learning together for the next 5 days. So before he takes over the session, exclusively on this forum, I would like to quickly introduce him. And he is none other than Dr. Amrit Raj. He's a physicist. He's a PhD in physics from IIC Bangalore, specializing in growth structure and properties of complex oxide materials. He's a Human Frontier Collective Fellow at Scale AI, evaluating cutting-edge AI models on complex physics problems. We are right now, next 5 days, would like to get the share and the learning from his expertise in quantum systems, material science, and advanced characterization techniques. He comes with a very rich, academic achievements, achieving top ranks in gate physics as AIR single-digit rank, as you can see, sixth in just JEST physics, AIR 29th rank, and CSIR and UGC NET as a junior research fellow. He is a very proficient member in quantum programming and thin film growth and computational physics tools. I'm sure you all would be enriched by his knowledge sharing and the hands-on experience sharing. Of course, there has been certain inputs from the other, eminent academic members, which he has accepted gladly and would incorporate a lot of practical applications related to quantum computing in the coming 5 days. So I would request Dr. Amrit to please, in the next couple of minutes, if you can give a quick, understanding for all the learners who had joined in about what is that they can be expecting over the next five days, uh, just to create a kind of an expectation setting, and then probably we will quickly go in for an knowledge transfer for the again, about the usage of the learning management system through which all the learners will get connected over the next few days through my colleague Amar, and then probably you would be handed over the stage for taking over for the sessions continue. Over to you, Dr. Amrit, for the next couple of minutes, expectation setting from your side. Dr. Amrit, please.
Thank you for the introduction. So, I'm Amrit, uh, currently a human collective fellow at Scale AI. I did my PhD from IIT Bangalore in physics. So this year, 2025, is a memorable one because it's been 100 years since the Schrodinger's equation was discovered back in 1925. So various programs related to quantum mechanics and quantum computing are organized worldwide in various universities, colleges, and we in our institute, Indian Institute of Science, also had many workshops and programs related to quantum computing and workshops. So I'm deeply grateful to XLR for giving me this opportunity to conduct training course on quantum computing. So unlike
Hello. Dr. Amrit, am I audible? Team, can you quickly check with him once?
Yeah, sure, sir.
Sushmita, yeah, please quickly check with him once.
Yes, sir, I'm checking.
So, yeah. So, Nikhil, you can keep him informed since anyways he
sorry
will
for
be
the
taking.
interruption. I'm
Yeah.
back.
Yes. You're audible.
Okay, yeah. So I was speaking about a secure quantum communication, which was achieved very recently by a collaboration between IIT Delhi and DRDO, which shows that there is a lot of potential in this field, and even countries like us in India can make great strides if we focus our skills and attention in this field. And apart from that, the artificial intelligence is an area where quantum computing can have great impacts. Specifically, those who know about the architecture of artificial intelligence, there is a particular section called optimization where quantum algorithms can significantly improve the speed of optimization and thus help in the training efficiency and speed up of AI models. So like that, there are plenty of other applications. Even in London, very recently, there was a news headlines about a railway timetable scheduling using quantum algorithms. So these are exceptional applications of quantum computing. And I'm so glad to hear other dignitaries in the function about quantum computing, their views on quantum computing and the potential applications this field has for our society and world in general. So in the next coming 5 days, I'm planning to go to the fundamentals of quantum computing, because without fundamentals, we cannot understand this field, because it's a paradigm shift. As Dr. Vidadisa said, it's a paradigm shift, and to appreciate that paradigm shift, we need to go through the fundamentals, the mathematics, and then we will come to the applications of this field. And this is a beautiful confluence of philosophy, mathematics, physics, and whatnot, and has applications ranging from biology, chemistry to finance, economy. So it's a very exciting topic, and I am so grateful to XLR for giving me this opportunity. Thank you.
Thank you so much, Dr. Amrit. Anyways, all the learners will be engaging with you, over the next 9-10 hours. And because we have to probably bring this curtain raiser program to an end very quickly, so we I would see on that note, basically the major part of this curtain raiser program, we are almost through, barring the one of the most important areas for the reason for this curtain raiser to get all of you acquainted with XLR's state-of-art learning management system, the companion or the buddy with whom you will keep on engaging, uh, not only for the next 5 days, but probably, if you wish to, probably for your entire, uh, you know, uh, learning years as much as you want to, right? So, I would I would request my team from the training and delivery management, probably Mr. Amar, who would be taking over for the next few minutes to walk you through the that engaging journey of how you can use your buddy, the XLR LMS, and use the platform to its optimum level. Over to you, Amar, for getting everybody aware about the same.
Thank you, sir. So, dear faculty members, once again, a very good afternoon and a warm welcome to the FDP on quantum computing. So, as sir mentioned, myself Amar, and I will just take a 7 to 10 minutes of your time, and quickly I will show you how you are able to access the LMS. So, let me share my screen. So, dear faculty members, everybody knows as LMS is known as a learning management system. And by using the LMS, we are going to provide you the recordings of the session. You can access all test material via LMS. You can submit your attendance. You can share your feedback via LMS. So, to participants, I believe now my voice is clear. Yes, thanks for the confirmation. Okay, so it's a one-stop solution for all e-learning material. Beyond the boundaries as well, we we have such functionalities where students can practice on the coding contest like HTML, CSS, JavaScript, Java, okay, whatever the language which we have. So it will assign the test cases that will be resolved and we can generate the report. Okay, so how you are able to access that, right? So those who registered, we already shoot out the mails to your mail IDs. So please check into the inbox, if not into the spam folder. If you not received, don't need to worry. By end of the day, everyone will get the mail about the LMS. Okay, you will get the detailed process email, or else you will find one more email that is for booking confirmation. Okay, so in the first mail itself, we are providing the LMS portal account details by XLR. In a step 1, you can see here, open this mail and click on the reset password link. Okay, so here we provided the reset password link. As most of you know that we are moving our platform, we are upgrading that so as to the next generation. It's AI built. With the help, you will get n number of new functionalities over the new portal. Okay, so our new portal LMS URL is mylearning.xlr.com. Okay, so you can just bookmark this URL on your browser, whatever the browser you're using, and you can easily access all the material. Okay, so now as a first time user of XLR or first time using the portal, you have to set your password first. Okay, so I'm clicking on to the reset password. So I will get one tab. Okay, so where I need to provide my email ID. Okay, so here why email ID again I have to provide, because it will be doing a second step authentication that your email ID, your registered email ID is correct. To that mail ID only you will get the mail. So once I provide my email ID, I will click here, then reset instruction. Then I will get one more email. By using that, I have to click on the reset password and you have to set your new password. Okay, so coming to this password, it will be completely new password. Whatever you want, you can save that, and in the future as well, you can forget that anytime from the system itself. Okay, so now just suppose that I provided my new password. I'm clicking on change my password. Once I click on change my password, I will get the notification reset your password successful. You can log in towards to the LMS. If I click on the login, or else if again I click on this mylearning.xlr.com portal, the system will take me to the next page that is nothing but a sign in to process. Login page or sign in page. Here I need to provide my email ID is nothing but a username. and the password which we have set recently. Okay, so now I'm providing my details here and I'm clicking on sign in. Okay, so we are done with the phase 1 till the setup become the account, resetting the password and sign in. Okay, so now let's consider I provided my credentials. So what next? So let me reshare my screen and I will show you how actually you can access all this material. Okay, so once we provide these details, so we launch here on the XLR dashboard page. Okay, first of all, I will just give you the overview where you will get what. Okay, so first of all, on your top hand right side, you are able to see your profile. Okay, so click on setting. You can set your profile, your name, your username. You can upload a photo if you want, and in the future, if you want to update your password, definitely you can update from here. Okay, so you will get the information here to update. Okay, so now let me go back to the dashboard. And here you can check, I'm able to see the back to home page, leaderboard, dashboard, purchase history. Okay, so back to home page. So in a home page, there are different product topics. Be like, as Mr. mentioned that we have collaboration with government bodies like SOEM Plus and the NASCOM MIT, right? Or our EDL, SDP's FDP program. All programs will be available in a products. That is nothing but a home page. Okay, so now let me go back once again to the user mode. So below that, you are able to see the leaderboard. Okay, so leaderboard is nothing but one thing like a hacker rank lead code where students will practice, they will get their XPs, right? So we are providing the different training program to the different universities. Okay, so from that universities, daily, weekly, monthly, all time, the leaderboard as per their coding contest or as per their MCQ contest are updated. Okay, now below that you will find the dashboard, which is an important thing for us. Okay, so where we'll get each and every information. So you can check here live session today. Okay, so as my member of XLR, I'm able to see the three classrooms live sessions are there for me today. But on the top you can check that day 1 FDP on quantum computing. If I click here, so I will get that join a Zoom meeting. Okay, YouTube. If you click on this link, it will take you to the Zoom, and at same time, the meeting is open over the YouTube as well. It's live. Whatever the queries and questions you are going to have, you can always keep posting that over the YouTube chat. Our team of XLR is active there, and your each and every queries will be going to take care. Okay, so you can post there. Even if we want to share any links of any particular application or attendance link or registration link or any another information, definitely we are going to share here over the YouTube. Let me show you that. Because in a YouTube, sometime what is to happen will not get the live chat console. Okay, so you can check here. Here is the XLR solutions channel is there. Below that, you are able to see the how many participants are watching the stream, and live chat option is there. So for now, I'm closing this console. Okay, let me close this console. And if I want to open that console, so what I have to do, I have to click on live chat. Okay, so you will get that console and you can post your queries and question here itself into the chat box. Okay, similarly, attendance, feedback, each and every information, registration link will be shared here. You can check here. So here registration link is already tagged by the team. Okay, so this is about the joining the session. There are two ways you can join via Zoom or else you can join via YouTube. Okay, so a couple of members are asking over the YouTube. So today we are not able to join via Zoom. No need to worry. So it will be open from day 2 or else you can directly join via LMS as well. Okay, so now let me go back once again on the dashboard. So I will show you how we are able to access all the materials. Okay, so we are done with the live session. Below that we have 20 like enrolled courses. For me it's 20. For you, you are able to see this classroom as FDP. Okay, so let me open that. So once I open that, I'm able to see the attendance and feedback, then live sessions, then session recordings, okay, and agenda. So first of all, coming to the attendance and feedback link. So dear faculty members, here attendance is mandatory for all this day, okay. So to get the certificate of participation from a team of XLR and the collaborative colleges, so 60% attendance is a mandatory, okay. So this link will be active in between 4:30 to 5:30 p.m. on the same day for 1 hour only. So please make sure that you are submitting your attendance, and you are sharing your feedback as well. Attendance link and feedback link is the one only. Okay. Now, sorry. Now below attendance and feedback link, you are able to see the agenda, FDP agenda. So you can go through that. You will get the overview like what we are going to learn in this next 5 days. Okay, so agenda is updated here. You can check here. Below that, you will get the same console of live sessions. Like I said that key, you can join the session using a Zoom and YouTube. You will find there. And whatever the sessions we are going to conduct in the future, so day wise, all the recording you can check here. So day 1, day 2, day 3, day 5, all the recordings will be available here. If you face any difficulties in the session itself, the comment section is on. You can comment here. Our team will get back to you. Okay. So likewise, you can access the LMS portal. Okay. So I hope it's clear. If anything is there, you can keep posting me into the chat box over the Zoom and YouTube as well. We'll take care of that. Thank you. Mr. Host to you.
Thank you so much, Amar. It was very deep understanding session. So anyways, everybody, anytime you are facing any kind of a problem, we have a support help and as well as groups of form. Please do feel free to reach out to us and partners for probably requiring to extend this curtain raiser session. So without wastage of any time further, I hereby would like to declare that the first day curtain raiser session is over, and we would be handing over this particular session to be taken over from here on to by Dr. Amrit. And all the once more before we start off today's formal training session, I would once more like to extend thanks to all the invited guests, Dr. Vidate, Dr. Asha, and as well as Professor Suman Bhattacharya for making out time from their busy schedule and be out here and sharing their thoughts. Without wasting any further time, over to you, Dr. Amrit, to take the session forward from here on. And of course, a warm round of applause for the entire backend team of XLR who had worked, uh, with a lot of aggression and dedication over the last 1 week for ensuring whole house participation. As we see on current right now, I think we have almost crossed 1,500 live participants on today's date, and I hope you will all be able to get the proper insight from these sessions. Over to you, Dr. Amrit.
Thank you, sir. Good evening, all. So I'll just share my screen first. Okay, so is it visible?
Yes, Dr. Amrit, it's visible.
Okay. And one more confirmation I need. Am I speaking loud enough? Is my voice clear?
I think it's manageable. It's audible.
Okay.
Yes, it's audible. It's audible. Not to worry.
Okay. Okay, so good evening, all. Let's start this journey of 5 days on quantum computing. So today I'll give you a brief glimpse about different terminologies and basic concepts that will help you to understand and about quantum computing and also explore more. So I'll just go to full screen and yeah. So what is quantum computing? So we all know about computing. We have been doing this for the mankind have been doing this for many years. In the past, people were doing computations on their hand, fingers, and then the invention of calculators, and later on the computers were invented, which enabled complex calculations by Charles Babbage's difference engine. And basically, there will be a problem to be solved, and the calculations that is required to solve the problem, that will be taken up by the central processing unit of the computer, right? Even the laptop which we are working on, the mobile phones, all are equipped with some processing unit, a processor. Now, the difference is the processors which we use in these computers are classical in nature. And this is a complete shift from the mindset point of view, because earlier, before 1900s, people were aware of only about classical physics, where the laws of Newton ruled, which says that an object that is moving forward, it keeps moving forward if there is no applied force, or the force is equal to mass times acceleration, right, which is a second law of motion. In contrast, in the when the research community, the scientists started looking at the microscopic scale, such as the world of electrons, the atomic particles, protons, and neutrons, they found that the basic behavior of these particles were completely different from the objects which we see around us. So to appreciate, to understand that, and to appreciate that, we need to have a paradigm mindset shift. And this is where the weird world of quantum come into play. In the world of quantum, there are two concepts which are primarily important. One is the superposition, and the one is the entanglement. And we can understand these two concepts using an analogy. Suppose as coin, I'm spinning a coin, tossing a coin. When it is on the ground without spinning, it's having a specific phase on the top, either heads or tails. But when I'm tossing it in the air, it doesn't have any particular phase which is facing on the towards the top direction. So this is a very crude example to understand the concept called superposition. Here, the coin can exist in both head and tails, right? We can say that. Similarly, an electron can revolve around the atom, and it can take multiple positions. Let's say we are measuring the position of an electron, okay, at x equal to let's say some 2 nanometers, and x equal to 4 nanometers, x equal to 14 nanometers. So here the electron is going from x equal to 2 to x equal to 4 to x equal to 14. So it's a very hypothetical situation. And let's say we are measuring the electron's position by passing some light or something. We are trying to measure the electron's position. Now the electron has a peculiar nature here, that it does not go in a continuum. Means that it has some kind of stops at 2, at 4, and 14, and it doesn't stay for long in between 2 and 4 and in between 4 and 14. Rather, it has some stops. So when I measure the electron position, when I measure it, I find that x equal to 2 in my first measurement, and then I leave the system and let the electron again be in its initial state, and then I do a second measurement. A second measurement gives me x equal to 4. So nothing, in fact, changed. Nothing changed, but the measurement value, the outcome, has given me a different value. So why is that? It shows that the electron exists not in not with a particular property value. It exists in a superposition state. It can have 2, it can have 4, it can have 14. So it exists in a superposition of 2, 4, and 14. Mathematically, we express this like this. So I will be discussing about this notation shortly. For, let's say, x equal to 2 plus 4, and 14. So there are 3 states here. One is 2, 4, and 14, and electron is existing in a superposition of these three states, right? 2, 4, and 14. And when I measure, the first time I got 2, and second time I got 4. And if I increase the measurements up to some 100 or more than 100, I will get a set of probabilities for each of these states. Says that, let's say, electron is in the state of 2 for a probability of 0.2. It is in the state of 14 for, let's say, so I just write here as 0.2, and 14 it is at a probability of 0.6. Okay, so and for 4, this is 4, and for 14 it will be at a probability of 0.2 again. So when I measure, most of the times I get that electron is in the state of 4, ket 4. Okay, this notation is called ket. So this is the concept of superposition, where the electron and its properties such as position, or let's say momentum, it can exist in multiple states. And when we measure that property, the electron, it collapses into one particular value of that property. So in this case, first measurement gave me 2 as an answer, and then when I did the second measurement, it gave 4. Right? Again, it gave 2. So like that, depending on the probability of each of the states, the measurement can narrow down the state property of the electron, state of the electron to one particular value. And this is the concept called superposition, and we will be dealing with it throughout this course. So this is just a brief overview of it. So as you can read here, a quantum particle can exist in all its possible states simultaneously until it is measured. So it's a very important concept to start with. Okay, and our act of measurement has an effect. What does it do? It forces it to choose one of the states. So in this case, where we measure the position, it is collapsing into one particular state, either 2 or either 4. Right. So yeah, so and next one is quantum entanglement. So here, second. So entanglement is a property of quantum world where two particles can influence each other even if they are separated by a very vast distance. This has been coined as spooky action at a distance. Spooky is translated as ghostly, which means even if there's a wall or some other obstruction, still the particle which we are measuring or dealing with in a particular room, it can influence the properties of the particle which is in the other room as well. So that kind of a invisible force between these two particles, that is called entanglement. They are linked with each other such that the measurement of state of one particle immediately decides the state of the other particle, no matter how vastly different they are positioned at. Okay. So, okay. So in this, there's some, is there anyone? Yeah. Okay. It's working now. Fine. So just to give a brief idea about the history of quantum field, there has been 3 different stages in the development of quantum mechanics, and that which leads to the quantum computing as of now. In the early 1900s, there will be plenty of advancement in this field, such as the quantum hypothesis by Max Planck, which who coined this term quantum, to explain the black body radiations. Later on, Einstein came up with a photoelectric effect and establishing the quantum nature of the electrons revolving around the atom, followed by Bohr's atomic model. And then the mathematical formalism of this field was mainly set foot on in the 1925 by Heisenberg, which was the matrix mechanics. And later, Schrodinger also chipped in with his wave mechanics, which we are using extensively in the field of quantum mechanics. So here in the wave mechanics, we are representing the quantum state as ket psi, and which obeys the Hamiltonian equations, which is represented by H, which is nothing but which defines the energy states of these quantum states. Okay, so that is the contribution of Schrodinger, wave mechanics. And later on, in the 1935, there was a significant understanding about the entanglement phenomena by three people: Einstein, Podolsky, and Rosen, which led to extensive debates surrounding the physical reality of entanglement. And then we had a flourishing period of quantum electrodynamics, which is a separate field in itself. And then this EPR paradox and the verification of entanglement was verified in 1964 by Bell in the form of Bell's inequality theorem. And then the modern scenario is where quantum computing comes in, where in 1994 the Shor's algorithm was developed. 1996 the Gross algorithm was developed, which showed significant advantage for the quantum computing over the classical computing. So that has really excited this field, and many applications are found to be potential areas of quantum computing. So, okay, this is coming. So, so just to brush the basics here. So we will use continuously. We will be using bracket notation throughout this course, and this is a contribution by a scientist called Paul Dirac, who invented this notation for mathematical convenience, so that we can conveniently speak the language of quantum, because this is a complete a change from the classical ideas. Here, the concepts like superposition and entanglement were never there in the classical physics. It is there only in the quantum. So the mathematics had to be changed accordingly. And with mathematics, the complexity, to take care of the complexity, we use a different notation for describing the quantum states, such as there is a notation such as this. With this is called bra notation, and there is another notation which is called a ket notation, which is represented like this. Now, what is the difference? Both represent the physical quantum state, but the difference is one is mathematical difference. One is a row vector. The bra is a row vector, whereas a ket is a column vector. So from the ideas of linear algebra, we know that a column vector is represented like this: A and B, with is a two-dimensional column vector, and a row vector will be described like this: A and B. So you have two elements here. It's a two-dimensional column row vector, and this is a column vector. So this is a bra vector. This is represented like this, and the column vector is represented like the ket notation, using the ket notation. Okay, So this is a bra notation, and this is for the ket. And now to describe the superposition principle that was never there in the classical physics, what physicists do using these Dirac notations, what they expressed the state of a system, let's say ket psi, to be equal to seeming, it looks like a plus sign, but it's actually not a plus sign. It's a superposition. It's a superposition of 0 and 1, but we call it as 0 plus 1, okay, for convenience. But actually it is not a plus sign, but rather it's a new terminology, superposition. So ket psi can simultaneously coexist in ket 0 and ket 1 states, and we represent it by this notation. Similarly, to understand the concept called entanglement, let's say ket psi is entangled. Okay, ket psi is entangled. How do we represent one example of an entangled state is as shown here, ket 0, 0 plus ket 1, 1. Now, why it is entangled, I can give you a brief overview. In fact, you can find it out yourself. So here there is only one index, 0 and 1, right? Because it's only one particle. This one, this ket psi, this psi is representing only one particle. Okay, but this particular psi has two indices, which means it is representing two particles. Okay, with the order, this is for the first particle and this is for the second particle. Same way, this is the first particle and this is the second particle. Okay, yeah. So if I measure the first particle, okay, like there are two particles, and I measure the first particle here, and this turns out to be 0. This turns out to be 0. So that means what would be the state of the second particle? Will it be 1? Can it be 1? No, it cannot be. It cannot be equal to 1, right? Or can it be? No, it cannot be 1. So it cannot be 1. Why? Because the 0 here, first particle 0, is connected, interlinked with the 0 of the second particle. There is no terms here where 0 of the first particle is linked with the 1 of the second particle. Hence, this is an entangled state. This is an entangled state. So again, this is a brief introduction to superposition and entanglement, and a crude example to show you the difference. Okay, so okay, so there is another important point. It's related to the bra and ket. So you can see bra is also defined as transpose complex conjugate of ket. Now, what do you mean by transpose and complex conjugate? So from the complex analysis and linear algebra background from our school days, we can understand these two concepts. Like A, B, I have written here, right? A and B. The transpose of that will be, I flip the column to the row. So when this column is written as a row, or if I have a two-dimensional matrix, let's say 1, 2, 3, and let's say 4i. Okay, I stands for iota, the complex iota. I is equal to root of -1. And now if I do a transpose of this, okay, a transpose, then it becomes 1, and 2 comes here, and 3 here, right? So this 1, 3 becomes a row here, and 1, 2 is a row, it becomes a column here, right? And then 4i. Okay, this is the state. So it gets flipped along the diagonal. And now I do a complex conjugate as well. If I do a complex conjugate, what happens? The complex numbers such as I here, that becomes negative. So I will write a negative sign here. So a bra is a row vector because it's a transpose complex conjugate of ket. Okay, so this is a fundamental understanding about this mathematical formalism of quantum mechanics. And then we have a concept of inner product from the linear algebra. We know that the dot product of two vectors. So this is a vector, right? This AB is a vector, and if I take a dot product of this vector, let's say I have another vector CD. So AB and another vector CD. So they are being, so if I do a dot product of these two vectors, in fact I can write like this here, C and D. Okay, two vectors A, B, and C and D, and the dot product is represented by this dot here. And what will I get? I'll get A will multiply C and B will multiply D plus B times D. So this is a normal plus, and we get AC plus BD as scalar value for the dot product. Similar in application is there in the quantum mechanics as well. Suppose I take the inner product, so I can combine two vectors in this fashion, a bra psi and a ket psi. So here this is a bra psi, right, and this is a ket psi. So I can multiply them in the normal matrix multiplication way, where the rows multiply the column, right? So A times A is equal to this is ket psi, and this is a dot product here. So A times A will be equal to A square, and B times B equal to B square. So this is a inner product of these two vectors, which are actually the same vectors. I can also do this with dissimilar vectors also. Like let's say there is a ket psi 1. Ket psi 1 is C and D. Okay, and ket psi 2 is A and B. So I will do this multiplication in this way, and then I'll get the same result as this AC plus BD. So what are these values A and B, and what are C and D, right? So A represents the probability amplitude. So we just discussed in the last slide. So this 1 by root 2 here, that is a probability amplitude with which we get the measurement outcome of 0. And the same 1 by root 2 is distributed here to 1 also. So that is a probability amplitude of getting this states as a measurement outcome. So that is an important concept of inner product. And we will, the mathematics of quantum computing keeps applying these mathematical tools to arrive at different interesting results. Okay, so that is one of the basic understanding bracket notation and Dirac notation. So we'll be opening for questions, I think, in the last 10 minutes, right? Right, Amar?
Sorry, sir. Can you please repeat?
Yeah. So we will be opening for questions and doubts clearing.
Yeah, we can allow them for last 5 to 10 minutes.
Okay, fine. Okay, so moving on. So here, this is a very important concept, a beginning concept. It's called Qubit, or short for quantum bit. So in the classical computing, we are familiar with classical bits, right, which take up 0 and 1 values. And using this 0 and 1, we store information, and we also transmit information. In the quantum computing, we use an analogous entity which is called as qubit. And this qubit is very fundamental because it helps us to store the information and also to transmit the information. So in the case of secure communication, we are transmitting the quantum qubit over a distance, right? And in the case of quantum processes, we store the information in the qubit in the form of superposition states until they are measured, right? So measuring, if we measure this, then it collapses into either one of 0 or 1. Okay, and now there is something else. These things. So why there is a superposition of the states and not a definite state? Because it is for the purpose of computation. Because when the state is involved in some transformation due to computation, it undergoes it undergoes interferences, constructive and destructive interferences, to arrive at the right solution. So in the quantum world, there is something called particle wave duality, where the objects are not just particles. If we consider an electron is not just a particle, but it also has a wave nature. And due to that, there is a possibility of constructive interference, where in the wave we have the crest and trough, right? So when two crests of two waves, they come together, it enhances the wave intensity. And if the trough of the wave comes in line with the crest of the other wave, then it diminishes the intensity, and thus we get a pattern. So here the solution to a quantum problem is arrived at by enhancing the the state which is the answer to the problem by a series of interferences with several qubits. So that is just a brief idea how things are being done in quantum computation. So qubits normally they exist in the form of superposition state, waiting for the transformations and interference. So in this regard, I have one small video. I think it's working. Okay, all right. Okay, all right. So a thing about a quantum bit, a significant feature of quantum bit is that it cannot be copied. It is stated in a famous theorem called no cloning theorem. So no cloning theorem states that a general qubit state, which exists in the form of this alpha 0 plus beta 1, it cannot be cloned where another cubic state, let's say a psi dash also having the same alpha and beta, is not possible to be created by exactly copying it. And as a result of the copying, we will have two states with identical parameters, right? That is not allowed due to a property of quantum bits called unitarity. So that will be discussing in the next day, tomorrow. But just for your information, that unitarity is a property which disallows the cloning of quantum states. So yes, so a kind of cloning like this is not allowed in quantum state. So now in the earlier slide, we discussed about how the properties of electron, such as the position, can be measured. And once it is measured, it collapses into a particular value of position. And now to measure a position and collapsing the state of the electron to a particular position state is a is an arduous task, because position can be not only just 2, 4, and 14, right? It can be 2.5, it can be 3, it can be 3.55, it can take a continuum of values between the 2, 4, and 14, which I discussed in the first slide. So it's not a convenient property which can be assigned to a qubit. However, the nature has allowed another property which can be used for preparing a nice qubit system, which can be used for quantum computing purposes. So that is the beauty of electron spin here. So electron spin is a is a is an intrinsic value of the electron, which allows us to have a clear, distinct two-level system, allowing for quantum computing purposes. It can be imagined as a spinning top, right? Where if I wrap my fingers around the spinning direction, my thumb points along the angular momentum direction, and hence the electron is imagined to have a spin, an intrinsic spin, and an associated angular momentum. Right, as shown in this figure here, it has an angular momentum out of the plane, and when I apply an external magnetic field to such a system, it couples with this particular angular momentum. And why? Because the angular momentum also has an associated magnetic field, right? It forms a magnetic moment. That's why the materials are magnetic, because the electrons within the material has a associated angular momentum and an associated magnetic moment, and it couples with the external magnetic field. And if the magnetic field is along the direction of this angular momentum, then the energy is less, because we know from the equation B dot m, right? So that will be less. And if it is anti-parallel, if the applied magnetic field is anti-parallel, that results in a higher state of energy. Thus, we get two kinds of energy here. One for an upspin and the one for a downspin. But for an applied magnetic field, if I apply external magnetic field, these two electrons having an upspin and having a downspin, they will interact differently with this magnetic field. The energy of these two will be less, and the energy of these two will be more. And hence I will get a nice separation of two energy states, and this can act as a 0 and this can act as a 1. Right. So this is how the separation of the energy states happen in the quantum physics. So whereas in the classical physics, how do we achieve this? We use some kind of voltage, right? We apply 0 volt and we apply a 5 volt, and this 0 corresponds to the 0 and 5 corresponds to 1. Also, we use the magnetic, the electron spin nature also in the classical field, where the upspin and downspin are given 0 and 1 representation in the classical computation. Okay, so now this is one representation of the qubit. So so we have completed understanding about qubit, which is a fundamental unit of quantum computing. Now, how do we represent that? One representation we already seen with the help of get 0 and get 1, right? So that representation is also called as vector space representation. Now, why it is called as vector space representation? Because it is a general vector. It's a general vector in a space of vector formed by 0 and 1 basis states. So those who are familiar with the linear algebra ideas, we know that if there is a two-dimensional plane x and y, we can have infinite number of vectors in this particular. Let's say this is a 0, we can have infinite number of vectors in this vector space formed by these two basis vectors. X and Y are called basis vectors. And similarly, 0 and 1 are the basis vectors of this particular vector space. And we get an infinite number of quantum states by varying the values of alpha and beta in this vector space. And the condition is that the mode alpha square plus mode beta square equals 1. Now, why is that? Why is that mode alpha square plus beta square equal to 1? Because the probability of getting 0 is equal to alpha square. Alpha square, and alpha being a complex number in general, we are interested in the magnitude only. So we write mode alpha and square it plus mode beta square equal to 1. Okay, so this is one particular representation called vector space representation. And now if I represent another vector, let's say get C, another quantum state get C, and write it as iota, complex number I, times alpha get 0 plus beta get 1. The same state, get psi. I times get psi. What is the relation between get psi and get C? Are they the same or are they different? Okay, so so if I write this, if I take the I inside, so it becomes I times alpha, right? I times alpha, and the other one will be I times beta. So this is get 0 here, and then I times beta. Okay, and then I take the modulus square, like in this case, get alpha mode alpha square plus mode beta square. Okay, so what do I get? Okay, so I'm taking a little time because it's a problem. We should be equipped to solve problems, right? And that is a test for our understanding. So if I take the mode square of the coefficient of get 0 and get 1, what is the coefficient of get 0? It is I alpha. So I alpha mode square plus I beta mode square, right? So when I take I alpha mode square, I mode is just equal to 1. Modulus of I is equal to 1. So it is nothing but it's same as, what is it? It is same as alpha mode alpha square plus mode beta square, right? It is same as mode alpha square plus mode beta square only, this one. So there is no difference. There is no difference between psi and C. They are the same. They're just the same. So hence this vector space representation is not a one-to-one representation, which means I can express a single state in multiple forms. I can write it as alpha 0 plus beta 1. I can also write it as I alpha 0 plus beta 1. So there is no one-to-one relationship between the states. And in relation to this, there's an important concept here, which is a phase. So if I represent two states, get 0 and minus get 0, and I represent another two states, get 0 plus 1 and get 0 minus 1. And now the question is, are these two states the same? And are these two states the same? So we find that if I take the modulus, right, of this coefficient, it is nothing but it is equal to 1. Now if I take the modulus here also, mode alpha square plus mode beta square, and here also alpha equal to 1 and beta equal to 1. Here alpha is 1 and beta is minus 1, right? So beta is minus 1 here. So if I take the mode, both are again 1, but there's a key difference. There's a key difference. There's a relative phase here. What do you mean by relative phase? Between the states, between the basis states are 0 and 1. Between them, there is a change in the phase. Now, what do you mean by change in the phase? So here I have x and y two-dimensional vector space, and there is an angle subtended by this vector. Now, this angle is the phase of this particular vector. Similarly, here, these two are having an angle theta, and that is the representation of the relative phase. Okay, so here you see that there is a -1, and -1 corresponds to a pi phase difference. Pi, because we know cosine of pi is equal to -1, hence the phase is pi. Okay, right. So is this the only representation? There is also another representation which is better than this present
Sir, I think there is some network issue from your end. We got stuck.
Yeah, I'm back now.
Yeah.
So there was some network interruption. Anyway, I'm back now. So is it visible now?
Yeah, it is visible.
Okay, so this will be the last slide. After that, we can take up the doubts or questions, if any. So I'll just explain about block sphere representation. Here, the zero, the north pole represents the 0, and the south pole represents ket 1. Okay, and all the other points on this block, on the sphere, represents the other other vectors, other quantum state vectors. Let's say this direction here, x, right? So this is x, y, and z directions. So this direction corresponds to the ket plus. Okay, what do you mean by ket plus? So ket plus is a okay. So ket plus is a superposition. It's a superposition state. So ket plus can be written as superposition of ket 0 and ket 1. Okay, and ket minus is so I just write like this. So ket minus is ket 0 minus ket 1. So I have two states like that. Okay, and on the block sphere, it can be represented as the x direction, which is 1 0 0, and ket minus is minus 1 0 0. Okay, it can be conveniently represented on the block sphere like this. And then there is ket I, which is 0 1 0, and ket minus I is 0 minus 1 0 along the y direction. And then I can write a general ket psi also on this in this representation. This is a ket psi, and I can write it as a superposition of ket 0 and ket 1 plus ket 1. And the coefficients are a function of theta and phi. And okay, what is theta and phi? So this is a representation in the standard spherical coordinate system, where theta is measured from the z-axis and phi is measured from the x-axis, right? So this is a function of theta and phi. Okay, theta phi, and this is also a function of theta and phi, f dash of theta comma phi. Okay, so the key feature of this representation is that the orthogonal states are diametrically opposite. So like you can see, the 0 and 1, they are the orthogonal states. Okay, why? Because all of the states can be written in terms of 0 and 1. Can I write any other state only in terms of 0, a general state? No, I need 1 also. So that's why they are called basis states. And these are terminologies taken from linear algebra directly. So quantum physics is nothing but it's a 90% linear algebra. And we see that in the block sphere representation, they are diametrically opposite. 0 and 1 are diametrically opposite. Similarly, plus and minus are diametrically opposite. Minus and I are diametrically opposite. And another way of looking at it is that orthogonal states, the inner product of orthogonal states are 0. So I have already shown that how to take inner products, right? So let's do an exercise here quickly. So 0 and 0, I'm taking inner product here. Okay. How do I now represent 0? 0 is 1 and 0. Okay. 1 and 0. And bra 0 will be written as 1 in the form of row vector. And ket 0 will be column vector. And this is equal to 1 into 1 and 0 into 0, which is 1 into 1 plus 0 into 0. So I'll get the value as 1. So 0 and 0, it gives me 1, right? Which means when both of them are same, then it will be equal to 1. It will be equal to 1. But when both are different, 1 and 0, there is 0 overlap between 1 and 0. And hence I get a value of, you can check it for yourself. So it will be 0. Here, how do I represent 1? 1 is represented in the form of 0 and 1. Yeah. So that is how we represent ket 1. And when I take the inner product, I get 0. I get 0 for 1, 0. And what about 0 and 1? What would be the value for 0 and 1? So this you can find it out. Okay. For the value for 0 and 1. Now there's a question here. What are the coordinates of ket plus in terms of spherical coordinate angles theta and phi for this state? So we know from the spherical coordinate system, theta is the angle from z. So this angle is the theta value, and phi is the angle from x. So this vector here. So this is the theta value. This is the phi value, and this is the theta value. So here, in terms of theta and phi, the ket plus can be written like follows: 90 degree and 0 degree. Right. Okay, so these are basics. With that, I think today it's almost the time is 5. So we will open for doubts and questions and feedback. Okay, I have one question here from Dr. Sandeep. Why are this computing referring as quantum computing? Is it due to consideration of dual nature of particle and uncertainty of variables, which provides more possibilities of a particular problem? Yes, so it's a very interesting question. So I started with saying that quantum computing is a computation based on the core principles of quantum mechanics, which is a branch of physics that studies small particles like electrons and atomic particles. At such a microscopic level, the momentum and the mass of the particles when it is very small, it has a nature to show the wave nature also. So when the mass of the particle is very small, the uncertainty between the position and the momentum of the particle, okay, that will become finite. This is famously called as the Heisenberg's uncertainty principle, where the uncertainty in the position times the uncertainty in the momentum, uncertainty or error in momentum, which it will be the product of these two will be greater than h by 2 pi. So it's a finite value, finite. So because of this wave particle duality, the quantum mechanical particles can at times behave as particles, which are evident in the experiments of photoelectric effect, where we hit the electron with an X-ray photon, and the electron behaves as a particle. It just get knocked out of the atom and it flies off as a particle with a certain energy. And it can also be observed in experiments like Davis and Germer experiment, or in the case of if you consider the photons, light photons, there is a two-slit experiment, Young's two-slit experiment, where I pass the photons through the light through the two-slit, and on the other side I get an interference nature due to the light. So it is that's a wave nature. The interference is coming out of nature due to the wave. So I have already described about the crest and trough canceling each other. So that's a wave nature. And in the case of quantum computing, because of the wave nature of the electrons, it is able to exist in a superposition state, right? And as a result, it is able to provide multiple paths. It can explore multiple paths, and we come to a particular solution by amplifying the correct path, and that's happening due to the quantum interference, right? Yeah, it's a very good question. I wanted to address this even in this particular slide here. So can anyone help me with how to open this particular link here? Because it shows a nice animation of how the wave nature of quantum mechanics can actually help us perform quantum computing. Hello.
Yeah, yes, sir.
Sushmita, can you help me with, do you know how to open this link here?
So which link you're asking about, sir?
In the bottom of the screen, I have a link, hyperlinked. I wanted to open it.
I think it's not downloaded.
Okay, now it's coming, I guess. So this is a kind of a maze here. If you are given a maze problem, normally what we do in a classical situation is that we explore each of the path of the maze separately or in a sequential manner, and then we come across the the right solution path, right? Whereas in a quantum computation, the qubit explores all the paths simultaneously because of its wave nature, and then it amplifies that particular path, which leads to the correct solution. Okay, so that's the difference, key difference between a classical computation and a quantum computation. Okay. Okay, the next question. What are the fundamental topic to be learned before we start understanding QT? Can you suggest a path? QT means quantum technology, I guess, right? Or is it quantum teleportation or something? So that is what we are trying to address through this, at least the day 1 and day 2 here. I will be going through the fundamentals, and it will help you to get a grip about how to read about this quantum computing related stuff further. So this is the foundational aspects. Today, whatever we have discussed, the concepts of superposition, quantum entanglement, and then we discussed about the notational aspects. We discussed about the most fundamental unit of quantum computing, qubits, and it's a key theorem of qubits, no cloning theorem, which has far-reaching applications in the quantum algorithms. Then we discussed about the implementation of qubit, one of the implementations, which is through electron spin. Meanwhile, there are other implementations of qubits as well, as we know that there are superconducting qubits, there are semiconducting qubits. So this is just for the basic understanding. I have described electron spin here. And then the representation of qubit is very important if we have to, as a way to understand, also to teach others. We have to understand about how it is represented and work through the mathematics of the states. So for that, we need to know the representation, and then it is not one-to-one, so we depend on another representation, which is called the block sphere representation, and that helps us another convenient way to represent qubit states. There's one more representation called matrix representation, which I will be teaching tomorrow. And with that, we will be able to get into the second level of understanding quantum computing, where we will be dealing with different protocol, right? Entanglement, and how to use entanglement to securely transmit data from one person to another person who is at a very distant location, and avoiding the eavesdropping. Such things. Yeah. Yeah, Venkat has raised a hand. Yeah, please speak up. Can you speak up? Sushmita?
Yes, sir.
Yeah, so Venkat has raised a hand. So is there?
Yeah, I have just
Yeah, good evening, Mr. Amrutraj.
Good evening.
Yeah. As far as now the things are concerned, it's okay. Like we are able to understand because I am the first. I am the user who is listening to QT for the first time, QC for the first time. Okay. And I am completely from computer science background without any maths and physics because I completed my graduation some 25 years back, where I forgot maths and physics at the time itself. Okay, now my point in asking the question is there any requirement for us to revise any mathematical topics or physics topics so that we can happily continue a journey with you for another days, coming days? That's what my question, Hamid Garu.
So, what did you expect, in fact, if, like computer science, quantum computing in the background of quantum computer science?
Yes.
Because the basics of quantum computing is basically qubits, right? And to understand the storing of information and also the transmission of the information, we need to have a grasp over what is a qubit and how it is represented, right? So the right mindset is we are learning something very new. Quantum computing is not like classical computing. There is a vast difference.
Yes.
And so the approach towards quantum computing is to learn from the basics. It's like learning 1, 2, 3. And if we even if we want our child to become a businessman, we have to send him to an LKG and UKG where he learns 1, 2, 3.
Yes.
Yeah. So in the same spirit, we are learning here about block sphere representation, which is a very, very basic stuff of qubit.
So you mean to say if we can follow these lectures, we'll be able to do something in QC, right?
Absolutely.
Right.
Absolutely.
Thank you.
And it will
Thank
be
you for
fun.
the confidence.
It will be fun. Yeah.
Thank you for the confidence you built. Thank you.
Yeah. And it's a very small, it's a brick. And there you have to, if you're planning to build a house, it's one brick. That's it.
Okay. Got it. Thank you.
Yeah, sure.
Okay, then thank you, sir. If there is no questions, we can wind up for the day. Thank you. We'll meet again by tomorrow at 3 p.m. Thank you so much, sir, for this informative sessions. So yeah, dear faculty members, I would like to address few points. Yeah, thank you. So I would like to address few points related to LMS attendance and all. So mainly I'll talk about the attendance. So as you all know, as we informed in the starting the session, like attendance link, like marking the attendance is very mandatory. You have to secure 60% or above 60% of attendance, then only you will receive the certificate. Okay, so attendance link will be shared in both Zoom chat and also the YouTube chat. From tomorrow, you can join through Zoom as well. Okay, only for the today, you people can join in YouTube. From tomorrow, from day 2, you can start joining in Zoom link as well. Okay, I'll just repeat. Attendance link will be shared in the both Zoom chat and YouTube chat. Okay, the link will be shared exactly at 4:30 p.m. Okay, the link will be active from 4:30 to 5:30. Please be noted, the link will be active only for 1 hour, that is 4:30 to 5:30. Okay, I hope you all understood related to attendance. Okay, so now about the LMS. So the LMS link will be shared to your register mail ID. If you have registered, for definitely you will all get the LMS link which we have gave the KT on LMS. So the link will be get for your register mail ID. Okay, if you have not received, kindly wait till today EOD or by tomorrow morning, you will receive the LMS link. Okay, so every day you can access the link. So the YouTube, the LMS, in the LMS, you can access the Zoom link and YouTube link. Using that link, you can join the session as well. Okay, and also in the WhatsApp, there are the WhatsApp community which you people already added. If you have not added, no issues. I'll be sharing a WhatsApp link on the chat. Kindly click on that link and join to our WhatsApp community every day around 250 or 255. We will be sharing the meeting link, like a Zoom link and also the YouTube link. Okay. You can access the link in both like LMS, and also you will receive it in WhatsApp communities. Okay, I hope you all understood related to the session how you wants to join. Okay, so I just need some quick response. If you have any questions to be asked, you can just ask me out so that I can answer. Yeah, Aris sir, as I informed, if you have not received the LMS details, kindly wait. By today EOD, you will receive it, or by tomorrow morning, you will receive all the details about the LMS. Any other questions? Yeah, today's attendance, which I have already shared in the chat in both YouTube and Zoom. I'll be sharing once again on the chat. If you have not marked your attendance, kindly I request don't miss to mark attendance. Please mark your attendance. I've just shared it again on the chat. Okay, any other questions? So I'm getting some messages like I'm unable to join the WhatsApp group. I'm sharing the WhatsApp group link once again. Please be waited. I'll be sharing the new one. Yes, I have shared the new WhatsApp group link. Kindly click on that link. You can join the link. Okay, any other questions? Okay, I think we are good to go. There is no questions to be addressed. Fine. Thank you all. Thank you for joining this wonderful session. We'll meet again by tomorrow at 3 p.m. You all can join through Zoom link as well from tomorrow. Okay. Yeah. Thank you all. Have a great day. Thank you.